So welcome, this is the video for the past paper questions based on the topic logarithms. So let us start with the first question. So the first question, he says find the value of log 100 to the base 10. That's the part A of the question. Part B of the question is log 50 to the base 10. I start from the, what is this, easy questions, then I go to the difficult questions. Part B is that, and part C. Part C is going to be log 4 to the base 10 minus log 40 to the base 10. So these are the questions. So how should I solve? Now log 100 can be written as 10 square to the base 10. So power comes from 2 log 10 to the base 10. Log 10 to the base 10 is 1. So answer is 2. What about this one? When bases are same, the addition becomes multiplication. It becomes log base 10, 50 times 2. 50 times 2 is 100, and log 100 to the base 10. Just now we have got it out. Answer is 2. Coming to the third part, part C, log minus becomes division, log 4 upon 40 to the base 10. So it becomes log 1 upon 10 to the base 10. So it is log 10 power negative 1 to the base 10. 1 upon 10 can be written as 10 power negative 1. So minus 1 times log 10 to the base 10. Log 10 to the base 10 is again 1. So answer is going to be negative 1. That is the first question. Now coming to the second question. Question number 2. What is being asked in question number 2? Find the values of part A is log 6 to the base 6. Part B is log 9 to the base 6 plus log 4 to the base 6. Whereas part C is going to be log 72 to the base 6 minus log 2 to the base 6. So how should I do? Log 6 to the base 6 is 1. Now this multiplication becomes, addition becomes multiplication. 4 times 9 is 36. So 36 can be written as 6 square to the base 6. 2 comes front, log 6 to the base 6, which is 2 times 1, which is 2. Subtraction becomes division, 72 upon 2 to the base 6, which is log 36 to the base 6. Just now we have done log 36 to the base 6 is 2. That is question number 2. Now coming to question number 3. In this question number 3, it is given that log a to the base 2 is p and log b to the base 2 equals to q and log c to the base 2 equals to r. Express this in the following, in the form of PQR. So what is that? Log AB upon C to the base 2. Then second part is log A square C upon B cube to the base 2. And part C is log B to the base A. We have to express in the terms of PQR. So for that, what should I be doing it out? So this is log A plus log B minus log C. Multiplication becomes addition and subtraction, division becomes subtraction. Now what is, and all are base 2. So log A to the base 2 is P, log B to the base 2 is Q, and log C to the base 2 is R. That is the first part, part A. Coming to part B, again multiplication becomes addition and division becomes subtraction. Log base 2 is B cube. The power comes front, so it becomes 2 log A to the base 2 plus log C to the base 2 minus 3 log B to the base 2. So it becomes 2P plus R minus 3Q. Coming to the last part, log A upon log B upon log A. It can be written as log B upon log A. This is called changing the base. You can introduce any base of your choice. Now base 2 and base 2. So log B to the base 2 is Q, log A to the base 2 is P, Q upon P. This is going to be the answer. Now coming to question number 4. Simplify this or find the value of A when A equals to log 64 to the base 63 times log 63 to the base 62 times log 62 to the base 61, so on till times and times log 3 to the base 2, where a belongs to z. Find a. So what am I going to do that? A equals to log 64 to the base 63 can be written as log 64 upon log 63, times this can be written as log 63 upon log 62, times this can be written as log 62 upon log 61, times so on, times log 3 upon log 2. Then log 63 cancels, log 62 cancels. This log 61 would have been cancelled with the next term. Log 3 would have been cancelled with the next term. Whereas for log 2 to cancel, there is no next term at all. For log 64 to cancel, there is no next term at all. So log 64 and log 2 are left over. So when we see the pattern, log 64 and log 2 are left over. Log 64 is log 2 to the power of 6 upon log 2. 6 comes front, 6 log 2 upon log 2. Log 2 cancels, so answer is going to be 6. That's question number 4. Coming to question number 5, it has been given that P equals to ln 2, Q equals to ln 6. Write the following in terms of P and Q. The first part is ln 12, the second part is ln 3, and the third part is ln 48. So how do I write ln 12 in terms of 2 and 6? 2 and 6 can be written as 2 times 6. 12 can be written as 2 times 6. So ln 2 plus ln 6. Ln 2 is P, ln 6 is Q. Now for ln 3, it can be written as 6 divided by 2. Ln 6 minus ln 2. So which is Q minus P. 48. How do I write 48? In terms of 6 and 2. So 8 times 6. 8 can be written as 2 cube. So ln 2 cube plus ln 6. So which is 3 ln 2 plus ln 6. 3 ln 2. Ln 2 is P. Ln 6 is Q. So 3P plus Q. Question number 5 was that. Coming to question number 6. Solve. What is the equation? Ln x to the base 5 minus log 4 to the base 5 equals to 2 plus log 3 to the base 5. So how should I solve it out? Multiplication, subtraction becomes division. Log x by 4 to the base 5 equals to, or bring the 3 also, log 3 to the base 5 also this side, log 3 to the base 5 equals to 2. So again subtraction becomes division. Log base 5 is there, x upon 12, 4 times 3 is 12 equals to 2. Converting logarithmic form into exponential form. So x upon 12 equals to 5 square. So x upon 12 equals to 5 square is 25. So x equals to 25 times 12, which is nothing but how much? 300. That's going to be the answer. Question number 7. It is given that log 2 to the base a equals to 5. So first part is find exact value of log 32 to the base a. Second part is log 2 to the base root a. And part C is find a in 3 significant figures. These are the 3 questions. So now log 32 to the base a. So 32 can be written as 2 power 5 to the base a. 5 comes front, log 2 to the base a. Log 2 to the base a is 5. 5 times 5 is 25. Now log 2 to the base root a. So log 2 a to the power of 1 upon 2. So this number comes to the numerator, 1 upon 2 comes to the denominator. 1 upon 2, log 2 to the base a. So 2 times log 2 to the base a. 2 to the base a is 5. 2 times 5 is 10. Next, find 8 to 3 significant figures. So we know that log 2 to the base a equals to 5. Converting logarithmic form into exponential form, 2 equals to a power 5. A equals to fifth root of 2. So take the calculator and do that fifth root of 2. So when I do that fifth root of 2 and in three significant figures, it becomes 1.149. 1.149, that's going to be the answer. Coming to question number 8. Again, it's a solve type of question. So I'm going from easy question to difficult question. You can see that I started from easy version, then I'm going to the difficult, slowly medium, then to the difficult version of the question. Solve for x for over here. So what am I going to do? First get all the logarithm terms on one side. Log 5 to the base 3 minus log 4 to the base 3 equals to 1. So it becomes log x upon 20 to the base 3 equals to 1. So x upon 20 equals to 3 power 1. So x equals to 20 times 3. So x equals to 60. That's going to be the answer. Next, question number 9. Let a equals to log b to the base 5, where b is greater than 0. Now write in terms of a. Write in terms of a. So what is the first part of the question? Log b power 4 to the base 5. Part B, log 25b to the base 5. And part C, log b to the base 25. So for the first part, 4 comes to the far front, log b to the base 5. What is log b to the base 5? A. For the next one, log 25 to the base 5 plus log b to the base 5. Log 25 can be written as 5 square to the base 5. Log b to the base 5 is a. And 2 comes to the front, 2 log 5 to the base 5 plus a. 2 times 1 is 2, so 2 plus a. Log 5 to the base 5 is a, or 1. Then finally I'll be getting the answer, which is 2 plus a. Next, log b to the base 25. How can I get log b to the base 25? Log b to the base 25 is 5 square. 1 comes to the numerator, 2 comes to the denominator. 1 upon 2 log b to the base 5. 1 upon 2, what is log b to the base 5? A. So my final answer is a upon 2. Question number 10. It's given that log 3 to the base b equals to 10. Find the exact value of log 81 to the base b, log 3 to the base b square, and find b in three significant figures. Log 81 can be written as 3 power 4 to the base b. 4 comes front, 4 log 3 to the base b. Log 3 to the base b is 10. So it's going to be 40. Next one, 1 comes to the numerator, 2 comes to the new denominator. Log 3 to the base b. So 1 upon 2 times 10, which is going to be 5. Now find b. So we know that log 3 to the base b equals to 10. So 3 equals to b power 10. b equals to 10th root of 3. So 10th root of 3. What is 10th root of 3? 1.116. But I want in three significant figures 1.12. Previously over here also he was asking three significant figures. We did not write in three significant figures. It is 1.15. That's going to be the answer. So read the question carefully. Three significant figures, 1.12. Now coming to question number 11. Find k when 4 ln 2 minus ln 8 equals to ln k. That is the first part. And second part is solve. 4 ln 2 minus ln 8 equals to minus ln 2x. So first one, part A, 4 ln 2 minus ln 8 equals to ln k. So it becomes ln 2 power 4 minus ln 8 equals to ln k. So minus becomes division. 2 power 4 is 16 divided by 8 equals to ln k. Ln and ln gets cancels. So I'm going to get 2 equals to k. Now coming to part B, 4 ln 2 minus ln 8 equals to minus ln 2x. This is nothing but what? Ln k equals to minus ln 2x. Ln k value is 2 equals to minus ln 2x. That minus take it to the power, so it becomes ln 2x to the power of negative 1. So that what will happen? Ln and ln can be cancelled. So what do I will be getting it out? 2 equals to 1 upon 2x. 4x equals to 1. So x equals to 1 upon 4. Now question number 12. Solve log base 3 x square minus 4x plus 4 equals to 1 plus log base 3 x minus 2. Get all the logarithm terms on one side. Log base 3, or else we can write x square minus 4x plus 4 equals to 1 can be written as log 3 to the base 3 plus log x minus 2 to the base 3. Now addition becomes multiplication. So log base 3 x square minus 4x plus 4 equals to log base 3 times of x minus 2. Log base 3 gets cancelled, so we get x square minus 4x plus 4 equals to 3x minus 6. X square minus 4x plus 4 minus 3x plus 6 equals to 0. X square minus 7x plus 10 equals to 0. So x minus 2 times x minus 5 equals to 0. So either you get x equals to 2 or x equals to 5. But x equals to 2 is rejected because 2 minus 2 cannot be 0, which is cannot be logarithm of 0 is not possible. So therefore, what is this? X equals to 5 is the only answer. Then question number 13. Solve for x. 27 to the power of x plus 2 equals to 1 upon 9 to the power of 2x plus 4. 27 can be written as 3 cube to the power of x plus 2 equals to 9. 1 upon 9 can be written as 3 power negative 2 to the power of 2x plus 4. So 3 power 3x plus 2 should be equals to 3 power minus 4x minus 8. Then 3 gets cancels. 3x plus 2 equals to negative 4x. 3x plus 6. This becomes plus 6. So 3x plus 6 equals to negative 4x, negative 8. 3x plus 4x equals to negative 8, negative 6. 7x equals to negative 14. X equals to negative 2. Now come to question number 14. Again solve log x square minus 2x plus 1 to the base 2 equals to 1 plus log x minus 1 to the base 2. So log x square minus 2x plus 1 equals to, that 1 can be written as log 2 to the base 2 log x minus 1 to the base 2. So what does that becomes? Log x square minus 2x plus 1 to the base 2 equals to log 2 times x minus 1 to the base 2. Log base 2 gets cancels. X square minus 2x plus 1 equals to 2x minus 2. X square minus 4x plus 3 equals to 0. So it becomes x minus 3 times x minus 1 equals to 0. So either x equals to 3 or x equals to 1. X equals to 1 is again rejected. So x equals to 3 is only the answer. Question number 15. Write the value of first question, log 8 to the base 2, log 1 upon 25 to the base 5, and log 3 to the base 9. After that, once I solve it out, hence solve log 8 to the base 2 plus log 1 upon 25 to the base 5 plus log 3 to the base 9 equals to log x to the base 16. So first of all, log 8 can be written as 2 cubed to the base 2. 3 comes front, log 2 to the base 2. 3 times 1, 3. For this one, 25 can be written as 5 power negative 2 to the base 5. Negative 2 comes front, log 5 to the base 5. So negative 2. Log 9, 3. 9 can be written as 3 to the power of 2. Then 1 comes to the numerator, 2 comes to the denominator, log 3 to the base 3. So 1 upon 2. Plug in those values. This value will become 3. This value will become negative 2. And this value will become 1 upon 2 equals to log x to the base 16. Then what am I going to do? 3 minus 2 is 1. 1 plus 1 upon 2 is 3 upon 2. 3 upon 2 equals to log x to the base 16. So 16 to the power of 3 upon 2 equals to x. So which is nothing but what? 4 square to the power of 3 upon 2 equals to x. 2 and 2 gets cancels. So x equals to 4 cube, which is equals to 64. That's question number 16 done. Now 15 done. Question number 16. It is almost all the similar model. First, find the value of part A, log 81 to the base 3, part B, log 1 upon 8 to the base 2, part C, log 5 to the base 25. Then after that, solve log 81 to the base 3 plus log 1 upon 8 to the base 2 plus log 5 to the base 25 equals to log x to the base 9. So 81 can be written as 3 power 4 to the base 3. 4 comes front. Log 3 to the base 3. 4 times 1, 4. 1 upon 8 can be written as 2 power negative 3 to the base 2. Minus 3 comes front. Log 2 to the base 2, which is negative 3. Log 5 to the base 5 square. 1 comes to the numerator, 2 comes to the denominator. Log 5 to the base 5, which is 1 upon 2. Now plug in those values. This is 4 and it is negative 3 and plus 1 upon 2 equals to log x to the base 9. 4 minus 3 is 1. 1 plus 1 upon 2 is 3 upon 2. 3 upon 2 equals to log x to the base 9. So 9 power 3 upon 2 equals to x. So x equals to, which is going to be 27. That's going to be the answer. So coming to the question number 17. Log x to the base 6 plus log x minus 5 to the base 6 equals to 2 for x greater than 5. So what is he asking it out? To find the value of x. So log x times x minus 5 to the base 6 equals to 2. So then converting logarithmic form into exponential form. So what does it becomes? X square minus 5x equals to 6 square. So x square minus 5x equals to 36. X square minus 5x minus 36 equals to 0. Factorize it out. X plus 4 times x minus 9 equals to 0. So either x equals to negative 4 or x equals to 9. X equals to negative 4 is rejected because x is greater than 5. So therefore the only answer is x equals to 9. That's question number 17. Now going to question number 18. Find values of x. Values of x if 25 to the power of x square minus 2x equals to 1 upon 125 to the power of 4x plus 2. So 25 can be written as 5 square. 5 square to the power of x square minus 2x equals to 1 upon 125 is 5 power minus 3 to the power of 4x plus 2. So it becomes 5 power 2x square minus 4x equals to 5 power negative 12x negative 6. So it becomes 2x square minus 4x equals to negative 12x negative 6. So divide by 2 on both sides. X square minus 2x equals to minus 6x minus 3. So bring all the terms on one side. X square plus 4x plus 3 equals to 0. So when I factorize it out, it becomes x plus 3 times x plus 1 equals to 0. So either x equals to negative 1 or negative 3. That is answer for question number 18. Now coming to question number 19. 9 power x plus 2 times 3 power x plus 1 equals to 1. Solve for this. So 9 power x can be written as 3 power x whole square plus 2 times 3 power x times 3 power 1 equals to 1. So let 3 power x equals to y. So it becomes y square plus 6y minus 1 equals to 0. So it's a quadratic. We factorize y equals to minus b plus minus square root of b square minus 4ac upon 2a. 2 times 1. So it becomes negative 6 plus minus square root of 40 upon 2. What is square root of 40? 2 root 10. 4 times 10. So square root of 4 is 2 upon 2. So cancel with 2. Negative 3 plus minus square root of 10. But basically what is happening is this is y. But what is y? Y is 3 power x. We know that 3 power x can be positive. It cannot be negative. So only I take positive value. Negative 3 plus square root of 10. This is 3 power x. It cannot be negative. So apply log on both sides. Log 3 power x equals to log of negative 3 plus root 10. So x log 3 equals to log of negative 3 plus root 10. So log 3, when I come to this denominator, it becomes base 3. So log base 3, negative 3 plus root 10. That's going to be the answer for question number 19. Now come to question number 20. Find the value of part A log 75 to the base 5 minus log 3 to the base 5 and 25 to the power of log 8 to the base 5. So subtraction becomes division. Log 75 upon 3 to the base 5. 75 upon 3 is 25 to the base 5. 25 can be written as 5 square to the base 5. 2 comes to the front, log 5 to the base 5, which is 2. Now how do I write this one? 25 can be written as 5 square to the power of log 8 to the base 5. So it becomes 5 to the power of 2 log 8 to the base 5. 5 to the power of 2 goes to the power 8 square. And we know that this 5 and 5, it get cancelled if at all it is in that form. So answer is only 8 square, which is 64. Because we need to know one property, a to the power of log b to the base a equals to b. If we know this formula, then we can do that. A and a should be the same, then they get cancelled and answer will be b. Then question number 21. Again, find the value of part A, log 98 to the base 7 minus log 2 to the base 7. 49 to the power of log 6 to the base 7. So minus becomes division. So log 98 upon 2 to the base 7, which is log 49 to the base 7. 49 can be written as 7 square to the base 7. 2 comes front, log 7 to the base 7. So which is going to be 2. 49 can be written as 7 square, then log 6 to the base 7. The 2 can go to the power. So it becomes 7 log 6 square to the base 7. Just now we have learned that 7 and 7 gets cancelled, 6 square, which is going to be 36. Question number 22. Solve 15 to the power of 4a equals to 81 to the power of a plus 2. Express your answer in terms of ln 3 and ln 5. Ln 3 and ln 5. So 15 can be written as 3 times 5 to the power of 4a equals to 18. 1 can be written as 3 power 4 to the power of a plus 2. So now expand, it becomes 3 power 4a times 5 power 4a equals to 3 power 4a plus 2. So 3 power 4a times 5 power 4a equals to 3 power 4a times 3 power 2. 3 power 4a, 3 power 4a gets cancelled. 5 power 4a equals to 3 power, this is not 2, whereas this becomes 8. Why does it becomes 8? Because 4 times 2 is 8. So it becomes 3 power 8 equals to 3 power 8. Now applying ln on both sides. So ln 5 power 4a equals to ln 3 power 8. So 4a ln 5 equals to 8 ln 3. So a equals to 8 ln 3 divided by 4 ln 5. So 4 times 1, 4 times 2. So what is a? 2 ln 3 divided by ln 5. That's question number 22. Now coming to question number 23. Let f of x equals to log of base k 8x minus 2x square, where x lies between 0 to 4 and k is greater than 0. Then f of x equals to 3 has one solution. Find k. So what is that? I'm going to do that. F of x equals to 3. So log 8x minus 2x square to the base k equals to 3. So 8x minus 2x square equals to k power 3. So we get a quadratic 2x square minus 8x plus k cube equals to 0. It has only one solution, means b square minus 4ac should be equals to 0. So b square minus 8 square minus 4 times 2 times k cube should be equals to 0. 64 minus 8k cube should be equals to 0. 8k cube equals to 64. K cube equals to 8. K equals to cube root of 8. k equals to 2. That should be the answer. Next, question number 24. Solve. Log sin x to the base root 3 minus log cos x to the base root 3 equals to 1 if x lies between 0 to pi upon 2. So minus becomes division. Log sin x upon cos x to the base root 3 equals to 1. So tan x equals to root 3 to the power of 1 root 3. So x equals to tan inverse root 3. So tan inverse root 3 is nothing but how much? Pi upon 3. Because it lies between 0 to 90, so pi upon 3 is going to be the answer. That's question number 24. Now come to question number 25. Solve 14 to the power of 6x equals to 64 to the power of x plus 3 in terms of ln 2 and ln 7. So 14 can be written as 2 times 7 to the power of 6x equals to 64 can be written as 2 power 6 whole power x plus 3. So 2 power 6x times 7 power 6x equals to 2 power 6x plus 18. So what does it becomes? 2 power 6x times 7 power 6x equals to 2 power 6x times 2 power 18. 2 power 6x, 2 power 6x gets cancels. 7 power 6x equals to 2 power 18. Apply ln on both sides. Ln 7 power 6x equals to ln 2 power 18. 6x ln 7 equals to 18 ln 2. So x equals to 18 ln 2 divided by 6 ln 7. So 6 times 1, 6 times 3. So what is that answer? 3 ln 2 upon ln 7. That's question number 25. Coming to question number 26. Find a and b such that a plus b ln 7, b log 7 to the base 4 plus 60 log 14 to the base 8 equals to 0. So what should I be doing it out? A plus b log. So what can I do? It can be written as ln 7 upon ln 4 plus 60 ln 14 upon ln 8 equals to 0. I converted into ln. Now, what am I going to do that? A plus b ln 7. Ln 4 can be written as 2 ln 2. 60 ln 14. Again, 8 can be written as 3 ln 2. So everything is having the same denominator ln 2. So 3 times 1, 3 times 20. So my common denominator is going to be 2 ln 2 is going to be my common denominator. So it becomes 2a ln 2 plus b ln 7 plus 40 ln 14. 40 ln 14 should be equals to 0. So from there, what I can get? 2a ln 2 plus b ln 7 plus 40 ln 14. 14 can be written as 2 times 7 equals to 0. So 2a ln 2 plus b ln 7 plus 40 ln 2 plus 40 ln 7 equals to 0. Grouping the like terms. So ln 2 common means it becomes 2a plus 40 ln 2 Similarly, ln 7 common. It becomes b plus 40 ln 7 equals to 0. So what am I doing it on? I am taking ln 2 common and ln 7 common equals to 0. So equate it out. There is no ln 2 term on the right side and there is no ln 7 term on the right side. So 2a plus 40 should be equals to 0 and b plus 40 equals to 0. So 2a equals to negative 40. So a equals to negative 20 and b equals to negative 40. So what I have done it out, I have equated to the terms on the right side. There is no ln 2 on the right side and there is no ln 7 on the right side. So both are equals to 0. So 2a plus 40 should be equals to 0 and b plus 40 should be equals to 0, which gives me the value of a and b. That was question number 26. You can see that we started with easy questions and slowly we are going to the difficult questions. Now coming to question number 27. Coming to question number 27, it's a big question. You can see that it is 18 marks question. We started with simple questions and we are going for the difficult questions now. He's telling that the first three terms of an infinite sequence are 2 ln x, q ln x and ln root x. If it is geometric, find the possible values of q, hence or otherwise show that the series is convergent. If at all it is geometric, so what is that? You have to find it out. The second term divided by the first term. Second term is q ln x and the first term is 2 ln x. So ln x gets cancelled. The common ratio is q upon 2. Now possible values of q. So this should be the same as u3 upon u2 also. u3 upon u2, the common ratio should be the same, which is ln root x upon q ln x. So ln root x is 1 upon 2 ln x upon q ln x. Ln x gets cancelled, 1 upon 2q. Because it is geometric, they should be the same. Common ratio should be same. Q upon 2 should be equals to 1 upon 2q. So q square equals to 1. So q equals to plus or minus 1. So those are the values of q. Now he's asking values of q. Hence or otherwise show that the series is convergent. So we have to prove that the series is convergent. Now we know that common ratio is q upon 2, which is nothing but what? Plus or minus 1 upon 2. So which is plus or minus 1. So for being convergent, we know that the common ratio should lie between negative 1 and positive 1. So we can see that yes, in both the cases, either positive 1 upon 2 or negative 1 upon 2, the QR is lying between negative 1 and positive 1. So therefore, in both cases, the series is convergent. That's going to be the answer for the part 2. Now part B. Given that q is greater than 0, s infinity is 8 ln 3, find the value of x. So s infinity. What is the meaning of s infinity? Part B. S infinity means u1 upon 1 minus r. So s infinity is 8 ln 3 equals to u1 is 2 ln x by 1 minus r. R I am taking it as 1 upon 2 because he told that q is greater than 0. Q is greater than 0 means I am going to take plus 1. So therefore I am going to take r as plus 1 upon 2. So what does it becomes? 8 ln 3 equals to 2 ln x upon 1 minus 1 upon 2 is 1 upon 2. So 8 ln 3 equals to 4 ln x. So ln x equals to 2 ln 3. So ln x equals to ln 3 square. So ln gets cancelled, x equals to 9. Coming to part C. Now so show that suppose that the series is arithmetic, show that q equals to 5 upon 4 and find the common difference in the form of m ln x. Now it has been said that it is a arithmetic series. For arithmetic series, what is that? Common difference should be same, u2 minus u1. which is nothing but how much? Q ln x minus 2 ln x, which is q minus 2 times ln x. Same is the case, it should be equals to u3 minus u2. What is u3 minus u2? Ln root x minus q ln x. So again, 1 upon 2 ln x minus q ln x. Then ln x common, 1 upon 2 minus q times ln x. So both should be equal. So what does that becomes? Q minus 2 ln x should be equals to 1 upon 2 minus q minus ln x. So ln x gets cancels. Q minus 2 equals to 1 upon 2 minus q. So 2q equals to 2 plus 1 upon 2. 2q equals to 5 upon 2. Q equals to 5 upon 4. So we have proved that q equals to 5 upon 4. Next, write down the common difference in the form of m ln x. So we know the common difference. What was the common difference? Common difference was q minus 2 times ln x. So q was 5 upon 4. So 5 upon 4 minus 2 times of ln x. So which is negative 3 upon 4 ln x. That's going to be the answer. Next part. Given that the sum of the n terms of the sequence is ln x to the power of ln square root of x to the power of 5. Find the value of n. So let me add a page over there. So he said that sum to n terms, Sn. Sn formula is n upon 2 times 2a plus n minus 1 times d. This should be equals to nothing but what? Ln square root of x power 5 should be equals to n upon 2 to a. A is the first term, 2 ln x, plus n minus 1 times d. Common difference is minus 3 upon 4 ln x. So careful simplification. So this becomes ln x to the power of 5 by 2 equals to n upon 2 4 ln x minus 3 upon 4 times n minus 1 times ln x. So it becomes 5 upon 2 ln x equals to n upon 2. We can see that ln x is there. I can take ln x common. So 4 minus 3 upon 4 times n minus 1. So ln x gets cancels. So and 2 also gets cancels. So 5 equals to 4n minus 3n times n minus 1 upon 4. So take the common denominator. So 5 equals to 4 is a common denominator. 16n minus 3n square plus 3n. So 20 equals to 19n minus 3n square. So I get a quadratic over there. What is that quadratic? 3n square minus 19n plus 20 equals to 0. Directly I am factorizing it out and writing 3n minus 4 times n minus 5 equals to 0. So n equals to 4 upon 3 or 5. But n cannot be a fraction, so n equals to 5 is going to be the answer. You can see that from the starting of the video, we were starting with the easier question, then slowly we were going to the difficult question. That was question number 27. Now coming to question number 28. Show that log cos 2x plus 7 to the base 16 equals to log square root of cos 2x plus 7 to the base 4. And second part is solve log square root of 10 cos x to the base 4 equals to log cos 2x plus 7 to the base 16, where x lies between 0 to pi by 2. So first of all, I have to prove this one. So for that one, this is part A and part B. So for part A, log cos 2x plus 7 to the base 16. How can I write that one as? log cos 2x plus 7 to the base 4 square. Power 1. 1 comes to the numerator, 2 comes to the denominator. So log cos 2x plus 7 to the base 4. Now again whole 1 upon 2 can be taken as a number and it goes to the power. So it becomes log cos 2x plus 7 to the power of 1 upon 2 to the base 4. To the power of 1 upon 2 means square root. Square root of cos 2x plus 7. That is part A. Coming to part B. What is given in the part B? Log square root of 10 cos x to the base 4 equals to log cos 2x plus 7 to the base 16. Just now we have proved that this can be written as log base 4 square root of cos 2x plus 7. So we can see that log base 4 gets cancels. Square root of 10 cos x equals to square root of cos 2x plus 7. Squaring on both sides. So what do I get it out? 10 cos square x equals to cos 2x plus 7. So for a moment, who has not done the trigonometry, they can memorize this one. Cos 2x formula. Cos 2x is 2 cos square x minus 1 plus 7. So I got, what does that becomes now? 8 cos square x equals to 6. So you need to memorize this formula, or it is there in the formula booklet. Cos 2x is 2 cos square x minus 1. So from there, I get 8 cos square x equals to C. 6 cos square x equals to 6 upon 8. Cos x equals to plus or minus square root of 3 upon 2. But he told that x lies between 0 to pi by 2. Means it is in first quadrant. In first quadrant, cos x is positive. So I'm going to take only the first value. Cos x equals to root 3 upon 2. So x equals to cos inverse of root 3 upon 2, which is going to be pi by 6. That's going to be the answer for question number 28. Now coming to question number 29. I had a page over there, question number 29. Solve 1 plus log x to the base 5 equals to log 7y to the base 5 and log 6x minus 1 to the base 7 equals to 1 plus log y to the base 7. This will form a simultaneous equations. We have to solve it out. So the first one can be written as log 5 to the base 5 plus log x to the base 5 equals to log 7y to the base 5. So it becomes log 5x to the base 5 equals to log 7y to the base 5. Log base 5 gets cancels. Then this one was square. Just to write it out over there. This is square. So what do I get from there? 5x square equals to 7y. That is the first equation. I got it. Now come to the second one. What was the second one? Log 6x minus 1 to the base 7 equals to 1. 1 can be written as log 7 to the base 7 plus log y to the base 7. So what does it becomes? Log 6x minus 1 to the base 7 equals to log 7y to the base 7. Log gets cancelled. 6x minus 1 equals to 7y. But we know that 7y is nothing but what? 5x square. So we get 5x square equals to 6x minus 1. So I get a quadratic. 5x square minus 6x plus 1 equals to 0. Factorize it. 5x minus 1 times x minus 1 equals to 0. So either x equals to 1 or x equals to 1 upon 5. So when I plug in x equals to 1, so we know that 5x square equals to 7y. So from there, y equals to 1 upon 35. Or else 5x square equals to 7y, y equals to 5 upon 7. So what is my answer is going to be? X equals to 1 upon 5, y equals to 1 upon 35. Or x equals to 1, y equals to 5 upon 7. Coming to question number 30. Now, the first two terms of infinite geometric sequence are in the order of 3 log x to the base 3, 2 log x to the base 3, where x is greater than 0. Find the common ratio. He's asking us to find it out the common ratio. So we know that common ratio is given by, the common ratio will be u2 upon u1. So r equals to u2 upon u1, which is second term upon first term. Second term is 2 log x to the base 3 divided by 3 log x to the base 3. So what is happening? Log x to the base 3 gets cancelled. 2 upon 3 is going to be the common ratio r. Now show that the sum of infinite sequence is 9 log x to the base 3. So for part B, sum to infinity. Sum to infinity is nothing but what? u1 upon 1 minus r. What is u1? 3 log x to the base 3 divided by 1 minus 2 upon 3. 1 minus 2 upon 3 is 1 upon 3. So what does that becomes? 9 log x to the base 3. Now the first three terms of arithmetic sequence are given. Find the common difference, giving your answer as an integer. So for part C, common difference is second term minus first term. So what is the second term? If you can scroll up and check, log x upon 3 to the base 3 minus log x to the base 3. In minus, what will happen? The becomes division to the base 3. So what can I see? X and x gets cancelled. So what do I get it out over there? Log 1 upon 3 to the base 3. 1 upon 3 is nothing but what? 3 power negative 1 to the base 3. Negative 1 comes front, log 3 to the base 3. What is log 3 to the base 3? 1. So what is the common difference? Negative 1 is going to be the common difference. Part D. Show that S6 equals to 6 log x to the base 3 minus 15. So S6. For part D, Sn formula. Sn formula is n upon 2 times 2a plus n minus 1 times d. So we want S6. So 6 upon 2 times 2 u1 plus 6 minus 1 times d. A means first term or u1. So which is 3 upon 6 upon 2 is 3 times 2 u1. So first term, what is the first term? We can see the first term is log x to the base 3. Log x to the base 3 plus 6 minus 1 is nothing but what? 5. 5d. What was d common difference? We got it as negative 1. So what is he asking us to prove it out? He's asking us to prove out 6 log x to the base 3 minus 5. So multiply it out. 3 times 2 is 6 log x to the base 3. Then plus times minus is minus, and 3 times 5 is 50. That's going to be the answer. Then finally, given that S6 is equal to 1/3 of the sum of the infinite geometric sequence, find the value of x, giving your answer in the form of a to the power of p. So what he says, for part E, S6 equals to 1/3 of S infinity. S6 is nothing but what just now we got? 6 log x to the base 3 negative 15 equals to 1/3 of 9 log x to the base 3. So 6 log x to the base 3 negative 15 equals to 3 log x to the base 3. So 3 log x to the base 3 equals to 15. So log x to the base 3 equals to 5. So x equals to 3 power 5. So what is the value of x? 3 power 5. That's question number 30. Now coming to question number 31. So what's question number 31? We need to show that log square root of 3 minus cos 2x to the base 3 or base 2 equals to log 3 minus cos 2x to the base 4. Then that's part A. Part B is solve. Using that, log 3 sin x to the base 4 plus 1 upon 4 equals to log square root of 3 minus cos 2x to the base 2. So I do the first part, part A. So for that, what am I going to do that? Take log square root of 3 minus cos 2x to the base 2 equals to log 3 minus cos 2x to the base 4. He's asking us to prove it out. So what can I do that? 3 minus cos 2x to the power of 1 upon 2 to the base 2. So now we know that the power 1 upon 2 comes to the, what is this? Front. So it becomes 1 upon 2 log 3 minus cos 2x to the base 2. So we know that if at all it is 1 upon 2, this 1 goes to the numerator and 2 goes to the, what is this? 1 goes to the main number and 2 goes to the base number. So it can be written as log 3 minus cos 2x to the power of 1 and 2 square. 2 square is nothing but what? 4. So that is only asking us to prove it out. So we are just playing with the numbers. Whole power 1 upon 2 came front. Then again 1 goes to the main number and 2 goes to the base, and we get it out in that way. Now coming to part B. What is he asking? Solve. What is that? 3 sin x to the base 4 plus 1 upon 4 equals to log square root of 3 minus cos 2x to the base 4 or base 2. Now we write it as this one as log base 4 3 sin x plus 1 upon 4 times 1 equals to, from part 1 this can be written as log base 4. So we convert everything in the terms of base 4 so that we can cancel it out. So log base 4 3 minus cos 2x. So this 1 can also be written as log 4 to the base 4. Now what we can see, this 1 upon 4 goes to the power. So everything will be log base 4 3 sin x plus log base 4 4 to the power of 1 upon 4 equals to log base 4 3 minus cos 2x. So now addition becomes multiplication. So what does that becomes? Log base 4 3 sin x times 4 power 1 upon 4 is square root of 2 equals to log base 4 3 minus cos 2x. I can cancel log base 4 gets cancels. So it becomes 3 root 2 sin x equals to 3 minus cos 2x. Then any other condition has been given in the question. Over here I did not write the condition over here. The condition is x lies between 0 to pi by 2. X should lies between 0 to pi by 2. So what am I going to do? 3 root 2 sin x. From formula booklet, cos 2x can be written as 1 minus 2 sin square x. You can use a formula booklet, 1 minus 2 sin square x. So it becomes 3 root 2 sin x equals to 3 minus 1 plus 2 sin square x. So what do I get from there? I quickly add a page there. It becomes 3 root 2 sin x equals to 2 plus 2 sin square x. So I get a quadratic there. 2 sin square x minus 3 root 2 sin x plus 2 equals to 0. So as it is a quadratic, we solve the quadratic. We cannot factorize it out. So minus b plus or minus square root of b square minus 4ac upon 2a. 2 times 2. So it becomes 3 root 2 plus or minus square root of 18 minus 16 upon 4. So it becomes 3 root 2 plus or minus square root of 2 upon 4. So which is 3 root 2 plus root 2 upon 4, or 3 root 2 minus root 2 upon 4. So what does it becomes? It becomes either root 2 or 2 root 2 upon 4. Root 2 is not possible because sine maximum value is going to be nothing but what? 1. So it is square root of 2 is greater than 1. It's not possible. So therefore sin x equals to root 2 upon 2. So x equals to sine inverse of root 2 upon 2. Its value is going to be pi by 4. And we can see that this pi by 4 is lying between 0 to pi by 2. That's going to be the answer. And finally, we do one more question. That is question number 32 over here. So he gave that the first three terms are ln x power 9, ln x cube, ln x greater than 0. Find the common ratio. Common ratio is nothing but what? u2 upon u1. So which is 3 ln x upon 9 ln x. So it becomes 1 upon 3. Then in part B, what is being asked? Sigma k equals to 1 to infinity. 3 to the power of 3 minus k, ln x equals to 27. And we have to find the, what is that? Solve this equation. Solve. So how should I able to solve this one? So this is a series. So first plug in n equals to k equals to 1. If I plug in k equals to 1, I get the first term. So u1 equals to 3 power 3 minus 1 ln x, which is 9 ln x. Then I plug in n equals to 2. 3 power 3 minus 2 ln x, which is 3 ln x. So my common ratio equals to u2 upon u1, which is 3 ln x upon 9 ln x, which is going to be 1 upon 3. So this is nothing but what? Sum to infinity. This is what? Basically sum to infinity. So S infinity equals to 27. S infinity means u1 upon 1 minus r equals to 27. So what is u1? 9 ln x upon 1 minus r. R is 1 upon 3 equals to 27. So 9 ln x upon 2 upon 3 equals to 27. So what does that becomes? 9 ln x times 3 upon 2 equals to 27. So 27 ln x upon 2 equals to 27. Then 27 cancels. So what do I get it out? Ln x upon 2 equals to 1. So ln x equals to 2. X equals to e power 2. That's going to be the answer. So these are 32 questions based upon logarithms and exponential for your exam and past paper questions. See you in the next video. Bye.